Hello students, now I am going to discuss on stepper motor interfacing. First I will try to understand what is stepper motor. A logical diagram of the stepper motor, and this is the actual physical stepper motor where you can see in your lab. And to drive this, what is the logic behind this? All this information we will try to gather now. First by defining what is stepper motor. Then after that, how I can interface this stepper motor to the 8051, how 8051 can drive the stepper motor. All this information we will try to discuss now. Let's start with the what is stepper motor. Stepper motor is a widely used device that translates electrical pulses into mechanical movement. That means here mechanical movement in the sense it actuates in a particular direction. Say the rotation happens in a particular direction, say clockwise or anti-clockwise. To drive in a particular fashion, what type of electrical pulses we have to apply. That's what lies here. Stepper motor is used in applications such as disk drives, dot matrix printers, robotics, etc. The construction of the motor is as shown in figure. You can observe here the physical part here where it comprising of a rotor part here and where a stator part is this. Actually, internally it has got a rotor part in this fashion where it has got two poles, north pole and south pole, and it has got a stator part which is winded by wires here. So we call it as the windings. Okay, A, B, C, D are the four windings here we have. So in order to rotate a rotor, the stator has to be energized. How I can energize? So by passing a logic 1 to the stator, get energized. In turn, so it is going to attract a rotor now. The rotor will be get attracted towards the particular energized winding. Say A is energized now by passing logic 1. So immediately the rotor will be attracted towards the particular winding. Now, in order to rotate the rotor in a particular direction, say clockwise or anti-clockwise, we have to keep passing the logic 1 windings, keeping other windings 0. So how we can do that? So you can refer this table where A, B, C, D are the four windings. Say I want to rotate in a clockwise direction. Clockwise direction where I have shown the arrow mark downward. So that indicates I have to pass a 1 to the A winding. Immediately the rotor will be attracted towards the energized winding. Now by passing 1 to the A, the remaining B, C, D has to be kept 0. So that means the other windings are not energized. It is in a state of de-energized. Okay. Now, in order to move a rotor in a clockwise direction, as shown here, the data movement should happen in this fashion. So that means the A winding should be de-energized, and immediately the B has to be energized by passing logic 1 from a microcontroller or any other devices. So in this way, by passing 1 to the B and B gets energized and keeping other windings, say A, C, D in a 0 state. That means it's in a de-energized state. Okay. In this way, so immediately the rotor will be attracted towards this direction. So this sets a clockwise movement. Okay. So especially by passing the data, that means logic 1 shifting the place A, B, C, D, likewise it makes a clockwise direction. If I pass from D to A, that is called a counterclockwise direction. Physically, you can find the device in your lab like this. So where this is your rotor part, and internally we have here stator part, which is it has got a windings here. So this is regarding stepper motor. Further, we will try to understand the hardware configuration as well as the software part also. First, starting with the hardware configuration, where I have already done the setups required for the interfacing of stepper motor to the 8051. In your lab, you can find these kits. Look at here. To understand in a better way, I have drawn a pic also here, where for the first block is the 8051. from the pole 2, the 4 pins I am using here: pole 2 of 0, pole 2 of 1, pole 2 of second pin, and pole 2 of 3. So that means the pole 2 of the lower pins, the 4 pins are used here, okay, from this kit. So this is your 8051 EDA board, and through the FRC cable I am connecting to the driver kit. So this is the driver. Prior to the stepper motor interfacing, we have to magnify the current and voltages. So in order to suit the required voltages and current compatibility, so we are going to use a driver here, so which is depicted here. After that, this is connected to the respective windings. Say A, B, C, D windings are connected here. So this is your stepper motor, and both the kits are required power supplies, where I have shown with this arrow mark. It requires a power supply here, which is connected to this place, and also through this cable I have connected to the this ADA board also. And through RS232 communication, serial communication, I am dumping the hexa file to the EDA board, and which in turn burns the program in a ROM. So this is regarding your interfacing hardware part. Now let's try to understand the coding part. Very simple code, where it comprising of the main program as well as the delay program. In the main program, you can observe here the 88 data is moved to the accumulator. So here mainly we are going to use a scheme called one phase on scheme. So in order to move a motor in a particular direction, what we are supposed to do? We have to pass a logic 1 to a particular winding and keeping other winding 0, which makes a particular winding will be energized and it will attract the rotor in a particular direction. If I pass in this direction, which is a counterclockwise, so which makes a counterclockwise rotation. Okay. Now I am passing a data 88, where this higher nibble is not connected to your port. Still I am using this data as a dummy data. Okay. And this data is very important, which is directly compatible to the one phase on scheme. So that means we are this is connected to the A, B, C, D. Likewise, so when I pass this particular data, accordingly motor is going to rotate in a particular direction. Okay. Now why this 4? Why 4 is moved to the R2 register? This is a counter actually. R2 is a counter. 4 just because I have to pass 1 to all these windings. So that means to create a 4-step, the motor is connected to the pole 2. Through the pole 2, communication is happening to the respective windings. So this data, the first data 100 data will be moved to the pole 2. So that means A will be energized and it is attracting now the rotor. Now I am using rotate right accumulator. So I have shown here clearly after each rotation what happens and what is the respective hexadecimal value. So that means after first RRA, so the rotate right accumulator logical distal movement, where your MSB will be moved to the LSB, and from the LSB data is moved to the MSB. So in this way the 0th bit will be shifted to the MSB, and the shift happens in this way, so the resulting value will be 44 kHz. So after this rotation, so you are getting 0, 1, 0, 0. That means your B winding is energized now, and now it is moving in a clockwise direction. Before passing to the pole 2, the next data we are calling a delay. So the delay program, when it calls, say for each step we have to create a 1 second delay. That is decided by passing a particular value. Prior to that, we have to manually calculate and what should be the value we have to decide. So to witness a proper step angle, I have given a 40. A very minimum value is if it is given here. What happens? The stepper motor is going to rotate in a very fast manner. I cannot find each step angle or a slow movement of a steps. This you need to feed a maximum value so that I can notice the step angle for each instance. Then R2 up. That means we are decrementing the counter. So that means the first step is done. So in this way, this keeps track of this count. So in order to create 4 steps, so this counter is used here. As soon as R2 becomes 0, again we are going to reload the data. That is, this data is moved here, and again the counter is initialized. So that means by using this program, making the stepper motor to rotate continuously in a clockwise direction. Okay, so if I want to make the rotor movement in a clockwise direction continuously, just change RRA to RLA. So this makes a counterclockwise direction. So this pass the data in this fashion. You are going to get a counterclockwise direction. Now let us try to understand in more detail what is the math behind this. Okay, now instead of continuous rotation of a stepper motor, I want to make the rotation only for half rotation. That means a full rotation means a 360 degree, but half rotation if I want to generate or if I want to trigger or 180 degree. So then what is the calculation or math behind this to control the operation? So first we have to understand what is step angle. Step angle is defined as the minimum degree of rotation with a single step. So to accomplish the complete one rotation, the number of steps per revolution is equal to 360 degree per step angle. Manufacturer have given in a database that for one full step means it is a 1.8 degree. That is a one full step. Okay. So that means to complete 360 degree, that is full rotation, the number of steps per revolution is equal to 360 degree per 1.8 degree. So accordingly you will get this count, 200 number of steps per revolution. This table will rotate a stepper motor for 4 steps. So in order to get 180 degree rotation, which is a half rotation, we need to repeat this table for 25 times. That means 25 into 4, which is 100 steps, and we know that each step, one full step is 1.8 degree. So accordingly 1.8 into 100, which is a 180 degree, which is a half rotation. Okay, so I have written a code here to make your stepper motor rotate in a clockwise direction only for half rotation, 180 degree. How we can do that? So we have to have a two counter here. One is 25. That means this table has to be repeated for 25 times. So in order to make 180 degree half rotation, and 88, as we have already discussed, to energize each coil, the lower nipple of the port 2, which is connected to the respective wind A, B, C, D, and the data is required to energize each coil is 88, and this 4 is to move the each data. That means 4 rows are here. That means 4 times we have to pass this one. So that's why the 4 count is moved here. And accumulator data, which is 88, is moved to the port 2. In turn, port 2 is connected to the stepper motor through the driver. Okay, and RRA for the clockwise direction. Then DJ, NZ, R2, decrementing the R2. That means this counting. Okay, and as soon as the 4 step is done, again I am going to reinitialize this data, and this particular loop will be repeated for 25 times, which creates a 180 degree half rotation. So in this way we can try to understand how I can make a different degree rotation, say 90 degree. Then in the exam, the examiner may give you to make the rotation for a particular say 180 degree, 25 degree, or 2 rotation, 3 rotation, likewise. Accordingly, this you have to calculate by using this formula, and you have to load the different value to this counter, which helps you to make the rotation for a required times. Thank you.